Okay, so today we are going to go over 7.3, which are complex proofs using multiple assumptions. Um, I have released the answers to exam 3 online. Um, so if you want to look over exam 3 as part of your final exam prep, you can do that. If there are specific questions from exam 3 you want to ask about, you can either email me or you can, probably the best thing to do is to bring it up during our review session next Wednesday. On Monday, we're going to do 7.4. There is a tutor-led review. I believe that I've sent you the link to that. I believe that is Tuesday. And then we will have our exam here on Friday of next week. So 1 week from today. So actually, let me look at the precise time so that I get that exactly right, because I think it might not be noon. It might be at like 2 or something weird like that. All right, so here we are. Yeah. So our exam is this a week from Friday, a week from today on Friday, April the 30th. We're Monday, Wednesday, Friday at 2. So we meet here from 2 to 4:30. And that will be that. I'll also open a link online for us to submit some evidence of having done the homework, and we'll proceed from there. Questions about anything logistical? Yes, sir. It'll be open sometime between now and exam time. So I'll probably open it this afternoon. I'll ask for samples of a couple of them. And yeah, so you'll have to submit it to me by exam time next Friday. You've got a week to figure out the nuts and bolts of that. Probably, if you've done it on Word, the easiest thing to do will be to attach your homework in Word documents. I assume most of you wrote it out on pen, so what I'll ask you to do is take pictures and submit the pictures. I mean, not of everything. I mean, I don't want to wait that much. You don't want to, waste an hour uploading pictures. I mean, I'll probably pick 3 assignments, or assignments, something like that. All right. So let's talk about section 7.3, complex proofs. Sometimes it's possible to be given an argument like this. If A, then both F and P. If not A, then both S and R. Not R, therefore P. This is, in fact, a valid argument. However, the S and I rules, and just assuming the opposite of the conclusion, aren't going to be enough to get you a proof for this argument. So we start with our premises 1, 2, and 3. We're trying to prove P. So we start with the opposite of the intended conclusion with not P. But then we're kind of stuck, because normally at this step we want to use S and I rules. But you can't do an inference with 1. You either need the match of the left, you either need an A, or you need an exact opposite of this big mess. You need a not both F and P. Same problem with 2. You'd either need a not A, or you'd need a not both S and R. So you can't do any inferences. You can't do any implications. You're kind of stuck. In fact, if you look at the truth assignment test, if you try to force an invalid set of values on this, we could get a value for R for premise 3 to be true. R has to be false. And we can get a value for P for the conclusion to be false, P has to be false. But all you get are 2 of your 5 values. And it's not enough to figure out what the invalid pattern is. which frankly is one of the reasons why sometimes the truth table is a more powerful tool than the truth assignment test. Then, if you plug these values in, again, you still don't know, you can't figure out what the values for A, F, and S are supposed to be. So what do? Well, here is what you are supposed to do. And this is kind of the equivalent of handing you the keys to the family car. This is a powerful tool, and you got to be careful how you use it. So here's the tool. You are allowed in a proof to assume anything that you would like to assume, so long as you only use it in a subproof, trying to get a contradiction from the assumption so that you can infer out the opposite of the assumption. I'll say it again. You're allowed at any time to have a step where you make a new assumption and start a new subproof. But the only thing you're allowed to do in that subproof is get to the point where you get a contradiction. And once you've gotten a contradiction, the only long-term result of the subproof is inferring out the opposite of your initial, your most recent assumption. So here, let me show you how this works. So in step 4, we've already done our automatic first thing we do in a proof. We've assumed the opposite of the intended conclusion. But in step 5, we're still stuck in step 4. So we need to make to make an assumption. And what should you assume? You should assume something that lets you do an inference. So I'm going to assume not A for my step 5. Once I've assumed not A for step 5, the subproof is going to look something like this. Step 5, I've assumed not A. Step 6, I'm going to use statement 2 and statement 5, and I'm going to infer out both S and R. Because statement 2 says not if not A, then both S and R. Statement 5 says not A. So I can plug that not A into statement 2 and infer out both S and R. Now, once I've got step 6, well, then that's easy. That's just an and I'm going to break out both halves of that and. So step 7 will be S and step 8 will be R. But once I get to R, then I've got what I want for this subproof. I've got a contradiction. I've got not R in step 3. I've got R in step 8. That allows me to close the subproof and derive the opposite of the second, the most recent assumption. So since 3 and 8 contradict, I can infer in line 9 the opposite of line 5. I get to infer an A. And it looks like this. So this is line 9 is what I've derived from my subproof. Because lines 3 and 8 contradict, I get to infer the opposite of line 5, the second assumption. So note, at this point, you close the subproof. Once you've reached a contradiction with your second assumption and inferred out the opposite of the second assumption, you then block off, forbid yourself from touching anything, using anything in lines 5 through 8. That was a subproof. Now it's blocked off. Now you can't use that anymore. The only point of that subproof was to get line 9. Once you get line 9, then you use statements 1 through 4 and statement 9, and you start doing inferences again. So with line 9, I can go all the way back to line 1. Line 1 says if I've got A, I can get both F and P. 9 says I have an A. And therefore, 10 gets us both F and P. 11 and 12, we get F, and we also get P. Once we get to line 12 with P, we have a contradiction, a second contradiction. We have line 4 is not P. We've got line 12 is P. That's a contradiction that enables us to infer out as our final step, the opposite of the initial assumption. We get P because 4 and 12 contradict. And then we're done. Now here's something fun. For step 5, there was more than one way we could have done this. So I assumed not A, but you also could have assumed A, and you would have done most of the same inferences in a different order. The A would have led to a contradiction in step 8. Step 9, you would have inferred out not A. You would have done some more similar inferences, and you still would have ended with step 13, a second contradiction, and inferring out the opposite of step 4. So there was more than one right way to do this, but of course there are a near infinite ways of wrong ways to try to do this. All right, let me pause. How are we doing? All right. So here are the 2 questions you should ask. Question 1, when am I supposed to use this tool? Again, this is the family car. It's a big deal. You don't want to just use this any old time willy-nilly. This is a tool of last resort. Actually, the family car might not be an adequate metaphor. It's more like a nuclear weapon. You don't start with this. This is what you use when everything else fails. This is a tool of last resort. After you've done every S rule, after you've done every I rule, after you've, assumed the opposite conclusion, you don't want to just start making assumptions for no reasons. You want to assume when you're stuck and you've used every S and I rule that you can. So that's the when. The harder question is usually the what. What to assume? Well, usually there are multiple things that you could assume that would work. But what you really, the key is you want to assume something that's going to let you do some inferences and ultimately lead to a contradiction. But you want to assume something that lets you do some inferences. And remember, there are only 3 I rules. There are the 2 I rule. There's 3 kinds of statements that have I rules. There's the conditional, where you want to assume either the affirmation of the left or the opposite of the right. There are or statements where you want to assume the opposite of one of the 2 paths. And there are negated and statements where you want to assume the match of one of the 2 sides of the and. So when you're making your second assumption, you always want to give yourself some new material that's going to let you do some inferences with these 3 kinds of statements and hopefully lead to a contradiction. If you assume something, if you try to assume something and it doesn't lead to a contradiction, then just erase that attempt and try again. But generally, there will be multiple correct ways to proceed when it's time to make another assumption. And the key will be to assume something that lets you make another inference. All right, let me pause there for a second. How are we doing? Questions, thoughts? How many of us got this? I mean, people already got this. Some of us got it, some of us less so. Okay. We can do a few more examples. I mean, this is the skill we're learning today. So here is another one. From if A, then both B and C, and if B, then both A and C, we want to prove if either A or B, then C. All right, well, step one, you want that. Step one, assume the opposite of the conclusion. So for line 3, first thing we do is assume the opposite of the conclusion. Gives us line 3. It is not the case if either A or B, then C. Then we look for S rules and I rules to use. We can't do anything on 1, we can't do anything on 2, but there is an S rule we can use with 3. From 3, we can infer out, 3 is a negated conditional, negated if then. And when you have a negated if then, you can infer out the match of what's on the left and the opposite of what's on the right. So line 4 will be A or B, the match of what's on the left side of the arrow. And 5 will be not C, the opposite of what's on the right side of the arrow. All right, then we look again. We say, okay, good. We've used line 3, but to use line 1, I need an A or a not both B and C. For line 2, I need a B or not both A and C, and I don't have any of that. I've already used line 3, so there's nothing else I can use 3 for, more than likely. For line 4, I would need a negated A or a negated B. So here I'm stuck. And once I'm stuck, and I'm sure I'm stuck, then I say, oh, this must be the time to use that tool of last resort, to use our ultimate weapon. Let's try making another assumption. So we will make another assumption, and we will, for line 6, I will assume not A. Now, note, really, I could assume an A, a not A, a B, a not B. Any of those things would let me proceed well here. But I'll assume not A. Why did I assume not A? Well, because I want to use it with line 4. So line 4 says either A or B. Line 6 that I've assumed is a not A, which is going to let me use the or statement. 7 is what I get when I've used 4 with 6. I get a B. So this says either A or B is true. 6 says A is false. Therefore, B is true. Once I've got a B in line 7, I can go back all the way up to line 2, and I can plug that B into if B, then A or C. So I take that B, I plug it into if B, then A or A and C, and line 8 is A and C from the combination of lines 2 and 7. Which brings me to line 9, where I'm going to take half of the and I'm going to get an A out. Now note, I'm also allowed to get a C out, but I'm not really interested in the C. I want the A. Because the A will give me a contradiction with not A in line 6. And once I do that, then I can close the subproof and infer the opposite of line 6. I can infer A. Once I've done that, it looks like this. And I'm on line 10. So 6 through 9 leads to a contradiction. I can infer out the opposite of 6. So not A gets me A in line 10. Now that I've closed the subproof, I can't use anything in line 6 through 9, but I can use 10 with 1, 2, 3, 4, and 5. So I look at 1, 2, 3, 4, and 5, and I look at the A I have in 10, and I will reach all the way back to line 1 that says if A, then I can get B or C. I take the A in line 10, and I get B and C. Once I've got B and C in line 11, I can break out the C from B and C, use that with 5. So 5 says not C, 12 says C. That means I've got a contradiction, and that enables me to end by getting the opposite and throwing out the opposite of our original assumption, which was to be proven. There we go, 13 steps. How are we doing? Very good. Yes?
How did we get 13 from all that again?
Well, we got a contradiction. So 12 said C, 5 said not C.
Oh, right.
So as soon as we get that contradiction, so now it gets more complicated because now we're looking for 2 contradictions. We need 1 contradiction from the nested subproof. And then once we get back to the main argument, we need a second contradiction to get us to our conclusion. So again, this is something, there were more than one right way. There's a way to do this assuming A on step 6. There's a way to do this assuming B on step 6. There's a way to do this assuming not B in step 6. Yes? I'm going to give you an open text box with the given statements and the to be proven, and you're going to write out whatever you like. Yes?
We have to write down what the rules are.
Well, the more information you give me, the better off we all are. So I'm going to try to get, when grading these, I can give partial credits. And the more I can figure out what the heck you were trying to do, the more I can probably give you partial credit for it. So it's definitely in your interest to write down the rules and the lines. Also, it helps you because, you know, when we're doing 13-step, 15-step proofs, you might get a little lost in your own proof. So when reviewing it, it might be good for you to remind yourself what rule you thought you were using at which points. So I recommend doing that. I won't penalize you for not doing it, but it kind of comes with its own penalty.
Could we have used C for step 9 and then contradicted it to 5?
Yes, that is absolutely correct. You could have done that. There are multiple correct ways to do this, and that was one of them. That's absolutely correct. Let's do another one. Maybe this time, maybe we'll do this together. If A then B, either A or both A and C, from this we're going to prove both A and B. If A then B, either A or both A and C. And from that, we'll prove both A and B. All right, what do we do first? Somebody help me out. Yes, absolutely. We start by taking the opposite of the conclusion. We're going to start with taking not both A and B. That is our assumption. The very last step of the proof will be to find a contradiction that gets us allows us to infer the opposite of this. All right, what do we do next?
Use the INS rules.
Right, we want to use INS rules. So we look at line 1 and we say, well, gee, what could I do with line 1? Well, if I had an A somewhere, I could get a B. If I had a not B somewhere, I could get a not A. But I don't have either of those. Line 2, if I had a not A, I could get a both A and C. If I had a not both A and C, I could get an A, but I don't have either of those. Line 3, if I had an A, I could get a not B. If I had a B, I could get a not A. So we try to use, you're absolutely correct, we would try to use the S&I rules. But guess what? There's no S&I rules that help us here. So now what do we do? Yes?
Bring out the nuke.
Bring out the nuke, that's right. So we're going to make another assumption. What should we assume?
I assume A.
You want to assume A. Sounds good to me. So our second nested assumption is going to be to assume A. Now, once we've got this A in step 4, we can go up and we start looking at things again. And I look at line 1, and 1 says if we've got an A, we can infer B. Okay. So I'm going to get a B from 1 and 4, the Ampiero rule. Now that I've got a B in line 5, I'm going to look at line 2. Still can't do anything with line 2. I've already used line 1. I bet it's line 3 that we're going to use here. And I'm going to try using that A again. 3 says you can't have both a true A and a true B. But line 4 said we have a true A. So let's get the opposite of the right side, which says not B from 3 and 5, the not and rule. And now we have a contradiction.
When I did it, I had my number 6 is not A, but put B in it. Is that okay? Can you have a contradiction with the assumption?
Absolutely.
Okay.
That is, again, so we're getting to a point where there were 4 different assumptions you could have made here, and there were a couple different ways you could have done the subproof even. So that is absolutely correct. But since I already wrote this down, I'm going to keep this. All right, so now this is my subproof. I'm closing it, and now I'm going, since I've got 5 and 6 contradicting, I'm going to infer out the opposite of line 4. Line 4 was A. We're going to get not A from 4 because 5 and 6 contradicts. That's called indirect proof or RAA proof. All right, but you know what? We're not yet done because we didn't get a contradiction relying only on line 3. So now we've blocked off lines 4, 5, and 6. We can't use lines 4, 5, or 6 again. But now we've got line 7 to use with lines 1, 2, and 3. So what do I do now? Yeah, 2 would be the most obvious place to use it. So we can use, here, let's start another column. So step 8, we're going to get a both A and C from 2 and 7 because of the OR rule. So 2 says either A is true or both A and C are true. 7 says A is false. You use 7 with 2 and you get out the right side of the OR. So we've got both A and C. Sold to the young woman for $10,000. All right, so what do we do next? Well, now we've got A and C. That's pretty easy. We just pull the A out of A and C from line 8 with our basic AND rule. Then we have 7 and 9 contradicting. We close that off, and we get the opposite of line 3. So we get both A and B. Why? From line 3, because the opposite of the assumption line 3, because lines 7 and 9 contradict. And then we're done. Bam. I did it slightly different here. I did the subproof the way he suggested doing it on the PowerPoint. But other than that, the PowerPoint was identical to what we did. Yes.
I'm still generally confused when I get towards the end. So with 9, we end up with the A. Then where do we go from there? Still confused.
Okay. So in 9, you had an A. So here's the thing to remember. Once we're done with the subproof, we are now back on our original quest. What were we looking for originally? We were looking for a contradiction. And when we have 9, when we have A in line 9, we've got a contradiction with line 7.
Oh, okay.
But, it's not easy to miss these things. Once we get 10 and 12 lines up there, 3 of which we're not supposed to use, you end up with a lot to keep track of. So, that's not surprising. That's gives us a lot to work with, but a lot to keep track of, which is why this is what the course builds to. We've been working for 4 months to get to this point. Shall we do another one? Yeah, let's do another. All right, looking at 7.3. All right, looking at 7.3. Let's do this one. Let's do number 3. If B, then A. If not, all right, not both A and C. Either B or C. And therefore A triple bar B. All right. Step 1. We're going to assume the opposite of the conclusion. Conclusion is A triple bar B. Therefore, our first step is to assume the opposite of not A triple bar B. All right, then we look at each of these and ask, can I use an S rule? No, 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 yes. So on line 4, we can use the S rule for negated triple bar, which gets us either A or B, and not both A and B. That little tick mark next to that to remind me that I've used that already. All right, then I look at this again. Can't use an S rule 5, can't use an S rule 6. Doesn't open up any I rule combinations up here. So guess what? I'm stuck. So when we are stuck, we should make another assumption. So what should I assume for line 7? Help the guy out here. Yes?
B?
B. Sure, we can assume B. Why not? So in line 7, we're going to assume B. Again, this is going to be its own nested subproof. I'm going to continue the subproof over here. So line 7 is going to be B. And then I'm going to look through lines 1 through 6 and ask, is there anything that lets me do an inference with B? And I assume this is why you chose B, because line 1 says if we have a B, we can get an A. So A is from 1 and 7, MP arrow rule. Then once we've got an A, we can start looking again. We've used 1. 2 says not both A and C. So I'm going to use 8 and 2 to get me a not C. Because if we can match one side of negated and, we can get the opposite of the remaining side. Then I'm going to look at line 3. And line 3 says either B is true or C is true. And line 9 contradicts 1/2 of the or. And we're going to get well, we can get B, but we already have B. So that doesn't do anything for us. All right, so let's keep looking. Ah, I see it now. No, it does, you can't use it with 5, but line 6 is what we can use it with. So line 6 says not both A and B, and if we match 1/2, we can get the opposite of the remaining half. So I'm going to plug A into not both A and B. It's going to get me a not B from 6 and 8. And once we've got not B, that contradicts our nested assumption, we can close off our subproof. And line 11 will be the opposite of line 7. So we will infer out not B from 7 because 7 and 10 contradict. Now that I've got not B, I'm going to not touch 7 through 10. I've got to go back to 1 through 6 with the not B. So the not B is going to, I'm going to use that with line 5. That's going to get me an A from 4 rule. I'm going to plug that A into line 2. 2 says not both A and C. 12 says A. That's going to get me a not C. And then in line 3, we've got either B or C. And I'm going to use this not B in line 11 to get us out of C. From 3 and 11 or. And now that gives us a direct contradiction between 13 and 14. So that can give us line 15, the opposite of the initial assumption. We get a triple bar B. From line 4, because 13 and 14 contradict. Whew. Now that is an example, I mean, frankly, I actually did an extra inference or two that I didn't really have to. It's not wrong, it just, like line 9 was unnecessary, it just didn't read it there. But, yeah. That was an inference I could do, it just wasn't all that useful. Didn't turn out to be all that useful. So here in line 7, there was probably a bunch of ways we could have gone. I bet we could have assumed A, B, C, not A, not B, or not C. I bet any of the 3 of those would have, any of the 6 of those would have gotten us where we wanted to go. Questions? How you feeling about this? You ready for the ultimate nested, double assumption proof on the final? You got some time to look it over if you're not quite that confident. That's okay. Well, yes.
So would it be a good idea to keep track of lines that we've already used for the inferences?
Well, yes and no. Yes, I mean, I usually put a little tick mark next to them just to let me know I've already used it. And if there's one left that I haven't used, I start by looking at the ones I haven't used. But sometimes you use it more than once. So keep in mind that just because you've used it once doesn't mean you can't use it again.
Okay.
So yeah, I usually put a little tick mark next to it because usually you have to use everything at least once. But there's nothing preventing you from reusing it. Well, congratulations. We've reached the last chapter, the last week. We've got one more section to introduce. I'll give you some practice questions before the final. We're doing it. We're in the home stretch. I'm exhausted. I'm going to sleep for about a week once we get to the end of the semester. Well, on that note, today you should celebrate. The weather should be nice. We'll have a little spring fest out there, is what I'm told. Enjoy your weekend, and then time to press forward for the final push, the final sprint to the end. You're all invited to take my 326 class in June if you're interested. Other than that, take care. Good luck. Hey. Here, let me turn off the live stream and we can chat.